Greetings. Was asked to do a video to go over the solutions to quiz 2. So that's what this is. So we'll go ahead and get into it here. Let's see, I gotta get to the right questions. Okay, here's question 1. This is from quiz 2 from module 2. This is workers at a particular mining site receive an average of 35 days paid vacation, which is lower than the national average. The manager of this plant is under pressure from local union to increase the number of paid time off, or the amount of paid time off. However, he does not want to give more days off to workers because this would be costly. Because this is capitalism 101. We don't want to spend any more money than they have to, right? Instead, he decides he should fire 10 employees in such a way as to raise the average number of days that are reported by his employees. Okay, so which of the following should he do? Or which, to achieve this goal, he should fire which of the following? So employees that have the most number of days off, the least number of days off, those that have about the average number of days off cannot be determined with the given information. Well, let's think about it. If we come in and we currently say that the shape of our distribution, let's just assume that the shape of this distribution, I'll go a little thicker here for you, a little better, go to 2. So we don't really need a particular shape here. It doesn't matter what shape you do. We could even say it's bell shaped. There's some people with very few days off, and then there's some people with a lot of days off, right? Like the managers or something, right? Well, notice that if this is the mean right here, or the average number of days off, right? Because notice that they're saying here our average number of days is 35 days right now. So if that's equal to 35, and we want to get that shifted over to the big side, then what we got to do is got to lop off some of the numbers down here. In other words, if we crop off this, that's going to shift the mean this way, isn't it, right? So if we get rid of some of the numbers down here, some of the lower numbers, it'll move the mean to the larger values, because that'll mean there'll be more larger values and the average will go up. Okay, you can think about that also with a set of numbers. If you say you had 1, 2, 3, 4, just take that for example, and I wanted the mean to get bigger here. Right now the mean would be, add those all up and we'd end up with what, 10, right? So divide that by 4 and you'd have 10/4 for your mean. Well, if you crop off this number right here, right, you take it off, now you're going to have what? You're going to have 9 divided by 3, or 9/3, which is going to be 3, which is going to be bigger than 10/4. Okay, so you're taking away the lower number, it's going to make the mean move up. Okay, so the ones he's going to want to lay off are the ones with the least number of days off. Okay, so let's move on to question 2 here. Scroll around to find it. Okay, here's question 2. This is below. You have the final scores for 20 introductory statistics students. They want us to find the mean, the standard deviation, the median, and the interquartile range. Now I'll show you a cool little trick here, which you can do from the actual quiz. Let's go ahead and go over to the quiz here. Is you can come in and you can simply highlight these numbers off the quiz. You don't have to type them in. I know, it probably mean to me, I should have showed you this before, right? So you highlight those numbers and you copy them. Let me do that one more time just to make sure I'm getting just the numbers I want there. Holy tomatoes, I swear, sometimes my fingers and this trackpad just do not get along with each other. There we go. Okay, so copy those, and now let's go back into RStudio. And I already tried this one just to make sure it would work. You go X equals C. Remember, C is for a column variable, and then just go ahead and paste those in, and voila, the numbers are in there now. Okay, so that saves you a lot of time. You don't have to type all the numbers in. Okay, all right, cool. Well, how do I get the numbers they're looking for? Well, I can do summary of X, and when I do a summary of X, there is my first quartile. There is my third quartile, so if I wanted to by hand, I could figure out the interquartile range. But there's my mean and my median, 77.7 and 78.5 respectively. Okay, so if I come back over here to the quiz, let's see, 77, the mean was A, right? Let's see, what was it again? The mean was 77.7, and the median was 78.5. So there's our mean and our medians. Now we want standard deviations in the interquartile ranges. So back here in R, I'm going to go SD of X, and I'm going to go IQR of X. I'm going to get those two numbers respectively, the 8.4 and the 9.5. And sure enough, there's my 8.44 and there's my 9.5. So it looks like this is our answer right there. Okay. All right, cool. Let's go back to the quiz here and get to the right spot. There we go. Okay, so let's go ahead and do question 3 now. So we got the daily air quality as measured by air quality index reported by the Environmental Protection Agency. This index reports the pollution level and what associated health effects might be a concern. The index is calculated for 5 major air pollutants regulated by the Clean Air Act and takes values from 0 to 300, where high values indicate lower air quality. AQI was reported for a sample 91 days in 2011 in Durham, North Carolina. The relative frequency histogram below shows the distribution of air quality index values on these days. Okay, key thing here, this is a relative frequency histogram, which means that the y-axis here is going to be given in percentages, actually in decimal values, but those are percentages. And so what that tells me is that if I took the heights of all of these bars and added the heights all together, in other words, if I took all these heights for every one of these guys right here and I calculated what they're going to be, and I took that and I summed them all together, the sum of all of the heights has got to come out to be equal to 1. Because the way the relative frequency works is you take the frequency for each of these bars and you divide it by the total number of values that were actually represented in the sample. Okay. All right, so they got 2 questions they want us to do here. They want us to estimate the median, and then they want us to say whether we would expect that value, the value of the median, to be either higher or lower, which of those two, than the value of the mean from the sample. So let's actually start off with the second question, and we'll come back to the first one. Okay, so if we were to take a look at this distribution, let me make my pen a little smaller for this. If we looked at this distribution and just kind of drew a smooth curve over the top of it like this, we'd see that this distribution looks like a pretty apparently, at least to my eye, because I've looked at these things for a while, is it appears that this is skewed, and it's actually skewed to the right. Okay, so we see that this distribution is skewed right. Well, what do we know about a skewed right distribution? Well, in a skewed right distribution, we know the relationship between the median and the mean is going to be such that the median is less than the mean. And the reason for that is that the mean loves extremes. If it's skewed right, the mean will get pulled to the right. If we had a distribution that was skewed left, then the mean would get pulled to the left and it would be smaller than the median. So already we know that the value of the median is going to be lower than the value of the mean. Okay, that's just from looking at the picture. Now what we need to do is get an estimate of what the median is going to be. Well, to get an estimate of the median, we're going to come and calculate the heights of these bars and start adding them up. So in the first bar, between 0 and 10, it looks like the height is at about, what, 0.25-ish, right? 0.025, excuse me. So you can say 0.25 there. Okay, and then the second bar appears to be at 0.05. Notice I'm adding these up as I go along. So at this point, I'm at what? I'm at about 0.75, right? 0.075 or 7.5%. And then the height of the bar between 15 and 20 appears to be about at 0.2. Okay, so if you keep in running go here, of what our sum is at this point. I'm going to go ahead and do this myself on the side here of the calculator because I can't do arithmetic in my head very well and talk at the same time. So I got 0.025 plus 0.05 plus 0.2, which so far gives me we're at what, about 27.5% of the data so far. So let's add into that, looks like what, about another 0.06, let's say. I mean, we're just getting these rough. They don't have to be exact, okay? So add into that another 0.06, and now we're at about 33% roughly. And then we have this last bar here, which we'll say, you know, that one's roughly at about 0.2 also. And notice we're at about 53.5% by that point, okay? By the time I get to this bar, I know that I've got at least 50% of the data is below the air quality value or the AQI value of 30. Okay, so what that tells me is that the median is going to have to be somewhere between 25 and 30, and the mean would be larger than the median. In other words, this would be my answer right here. Hopefully that makes sense to you. Okay, let me put that last number that I added in here, which I said again was about 0.2. And so all I know, I really don't need to know the exact sum here. I just know that this sum is greater than 0.5, and 0.5 is 50%. And what you got to remember about the median is what it does is it slices the distribution in half. And so what that tells me is that somewhere about here-ish, there's going to be 50% of the data below that value, and there's going to be 50% of the data above that value. Okay, so hopefully that helps. If that one's still, if you need some more hints on that one, don't be shy about asking me. Okay, so let's go take a look at question 4 here. Let's see, where am I? 4. There was question 4. Okay, it says, for the following, describe what you expect the distribution to be: symmetric, right skewed, or left skewed. Specify whether the mean or median would be the best represented typical observation in the data, and whether the variability of the observation would be best represented by the standard deviation or the interquartile range. And so the scenario they asked us to take a look at here is the number of alcoholic drinks consumed by a college student in a given week. Well, okay, so some of you may or may not know a college student or two, but you may know that, you know, the vast majority of college students are pretty mellow on the alcohol during the week, but there are definitely the party boys and girls that drink a lot, okay? And so if this is the distribution of the number of drinks per week, we're probably very safe in saying that that distribution would be a skewed right distribution. So this distribution definitely looks like it's going to be skewed, and it looks like it's going to be skewed to the right, or right skewed. Either way is fine. You can say skewed right or right skewed. Now, what would be the appropriate measurements for center and variability in a skewed distribution? This is true for all skewed distributions. You want to use the median for your measurement of center, and you want to use the interquartile range for your measurement of variability. So answer A here was the correct one on that one. Okay, last but not least, we got question 5 here. It says the following bar chart gives the most likely causes for good employees to quit: limited advancement potential, lack of recognition, low salary benefits. So the shape of this distribution is, okay, so this one, I got to admit, this was a bit of a tricky question. And the thing is that you got to remember, it's a very important idea, is that shape infers, or we have to be talking about numeric data. It has no relevance whatsoever when we're talking about categorical data. So if we're talking about shape, it has to be numeric. If you go back and watch the lab, you know, I make a big point of that at least one junction in the lab, okay? So it's not relevant to this data type. It is not, you can't talk about shape when you're talking about categorical variables, and you see that this data right here is a categorical variable. Okay, so since you have a categorical variable, shape doesn't make any sense. It's kind of the idea of ordinal versus non-ordinal, okay? You could make an argument for a shape in an ordinal data set, but if it's not an ordinal data set, then there's definitely no argument whatsoever about whether they're shape, and these don't have any natural ordering to them. Okay, so hopefully that answers all of your questions on the quiz, and please, if any of these did not make sense, post questions and discussions, and I'll do my best to make them better for you.